Okay, so I have to be completely honest with you right out of the gate here.
Hmm.
I have been staring at the study materials for phase two all week, and I just feel like I am hitting an absolute brick wall. We are doing a deep dive today into phase two data understanding, right?
Yeah, that is the one. It is the critical bridge between the business problem and the actual data preparation.
Right, the bridge. And on the surface, it honestly sounds incredibly simple. Like we are just looking at the data. It sounds so passive to me. But the deeper I get into the CPMAI framework, the more I just keep mixing things up. Specifically, I keep confusing quality with requirements. I mean, in my head, if data is high quality, doesn't that automatically mean it meets the requirements? And if it meets requirements, isn't it inherently good quality? I just feel like I am spinning in circles, and the practice exams are absolutely punishing me for it.
That is a completely normal reaction, and
Yeah.
honestly, it is exactly where most candidates lose points.
Yeah.
Phase two is actually one of the stickiest parts of the framework, precisely because it feels subjective, but the exam treats it with absolute objective rigidity.
Yeah, rigidity is the word. It feels like a trap.
Well, think about where you are in the project. You are standing right between business understanding, which is what we want to solve, and phase three data preparation, which is
Yeah.
getting your hands dirty and fixing things. So phase two is where we stop and ask a very dangerous question. Wait, do we actually have the raw materials to build this thing?
Dangerous because the answer might be no.
Exactly. And if the answer is no, but you proceed anyway just because you didn't check thoroughly, you are going to waste months of time and budget.
Right. And I need us to really slow down today. I want to go through this properly, not just glossing over definitions, but actually digging into the logic. I suspect, if I am confused, a lot of people listening are confused too. Can we strip it back to just the absolute basics?
Absolutely. Let us look at the structure first. Phase two isn't just this generic blob of looking at spreadsheets. It has three very specific task groups. And knowing the hierarchy of these groups is the very first step to passing the exam.
Okay, hit me with them. What is the hierarchy?
First, you have collect initial data. The priority on that task group is high. Second, you have verify data quality. The priority on that is critical. And third, you have machine learning model data requirements. That one is also critical.
Okay, I'm seeing a pattern here immediately. The critical tags, the big red flags for the exam, are on quality and model requirements. But just collecting the data is only high.
Exactly. And that is a huge signal for where you need to focus your study time. When you see critical priority tiers in the CPMAI framework, those are the areas where mistakes aren't just annoyances, they are project killers. You can collect data a bit sloppily and fix it later to an extent, but if you fail to verify quality or define requirements, the project is dead on arrival.
So for today, here's my plan. I want to treat this like a post-mortem or a strategy session. I'm going to throw the scenarios at you that constantly trip me up. You know, the ones where I assume common sense applies. And I want you to tell me exactly why the framework disagrees with me.
I love that approach. I'm going to act as your coach today. I will walk you through the logic, but I'm going to put you in the hot seat. I will give you specific scenarios based straight out of the study guide, and I want you and actually everyone listening right now to mentally pick your answer before I reveal the correct one.
Oh, I like that.
Yeah, don't just listen passively. You need to commit to an answer so we can see if your intuition actually aligns with the framework.
All right. I am ready to be corrected. Let's clear up this confusion. Where do we start?
We have to start with the first major term that trips people up. It is the first critical bucket, which is verify data quality.
Okay. See, in my head, this is just checking if the spreadsheet opens, if the columns have names, and maybe making sure there aren't a bunch of empty rows. Like it's a hygiene check.
And that is exactly where most candidates fail. That attitude that it's just a hygiene check is exactly why AI projects fail in production. The technical definition for verified data quality in phase two is much more rigorous. It is the task that formally assesses whether the available data is suitable for the AI modeling purpose. We are evaluating 5 specific pillars: completeness, accuracy, consistency, timeliness, and representativeness.
Okay, I have seen that list in the book. Completeness, accuracy, consistency, timeliness, representativeness. It just sounds like a standard corporate data governance audit.
It overlaps, sure, but the intent is entirely different. And here is the key revision in the latest material that you really need to burn into your brain. A superficial spot check is typically insufficient. This task requires a systematic documented assessment approach.
But hold on, let me play devil's advocate here for a second. In the real world, we deal with big data, right, Ed? If I have a data set with 10 million rows, I cannot possibly manually check every single row. My boss would fire me for wasting time. So surely a spot check of, I don't know, the top 100 rows is acceptable practice.
In the real world of traditional software, maybe. In the world of CPM AI and machine learning, absolutely not. Think of it this way. Here's your metaphor, the pre-flight inspection.
Okay, I like planes. Let's go with that.
Imagine a pilot walking up to a massive 747. It is a huge machine with millions of parts. The pilot stands 50 feet away, squints at the wings, maybe kicks one tire and says, yeah, looks like a plane. It's big, it's shiny, let's fly.
That is terrifying. I would absolutely not get on that plane.
Why not? He looked at it. He checked a sample of the tires. Well, one of them.
Because looking like a plane isn't the same as being safe to fly. There could be a hydraulic leak or a loose bolt in the engine, or the pressure could be completely off. You cannot see that from a spot check.
Exactly. A qualified inspector uses a checklist against a specific airworthiness standard. They are systematically checking specific bolts, pressure levels, and hydraulics. They're using tools to check the things they can't physically see with their eyes. They're following a documented procedure.
Right.
Verified data quality is that checklist. It is not asking, is this data? It is this airworthy for an AI model?
That makes a lot of sense, actually.
Yeah.
You need a standard, not just a glance. And I guess systematic doesn't necessarily mean manual, right? Like you could run a script that systematically checks all 10 million rows.
Precisely.
Yeah.
Systematic means comprehensive and rule-based, not necessarily manual. It means you didn't just guess based on the first 5 rows you saw.
Okay, I am with you. Let's test this. Give me a scenario where this goes wrong.
All right, let's do scenario A. We will call this medium difficulty. You're working at a large retail bank. You're in phase 2 for an AI credit scoring model, which is high-stakes stuff. You have a massive data set of 2 million customer records.
Okay.
The data team is under huge pressure to deliver. They want to be efficient, so they quickly review a random sample of 1,000 records. They look through them. They find no obvious errors. The dates look like dates. The money looks like money. They declare the data quality check complete. The project manager says, great, we saved a week, and moves the project straight to phase 3.
Right.
What gap in the phase 2 process does this decision introduce under the CPM AI framework?
Well, based on what you just said, my initial instinct before this conversation would have been, that sounds super efficient. Why check 2 million rows if the random sample looks good? Statisticians do sampling all the time. But you emphasized the pre-flight checklist, and you said systematic. So I am going to say the mistake is that they relied on a spot check instead of a systematic assessment of the whole corpus.
Correct. But let us dig deeper. Why is this dangerous for AI specifically? Why can't we just trust the sample?
Because, well, going back to the plane,
Yeah.
if you check 99% of the plane and miss the one screw that is loose, the plane crashes. In data, I guess if there is a pocket of data, maybe from a specific branch or a specific year that is corrupted, the model might learn something crazy from it.
Exactly. Machine learning models are incredibly sensitive to outliers and hidden patterns. If that unchecked portion contains a hidden bias, say all the data from 2020 is formatted differently, or all the data from the West Coast branch has 0 income recorded, the model will learn that rule. It will learn that West Coast people have no money. A spot check misses that. The rule is the task requires a systematic, documented assessment approach. If you don't document the quality of the whole ammonium, you haven't verified it. You have just guessed.
Okay, I got that one. Don't just kick the tires. But here is where I really get stuck. What about when the data actually is accurate? Because I have run into practice questions where the data is perfect, no errors, no missing values, and the answer still says the quality is bad. That just feels like a trick.
It is not a trick, but it is the hard scenario.
Oh.
This is the one that catches almost everyone because it challenges your fundamental definition of the word quality.
Okay, lay it on me.
Scenario B. An insurance company is building an AI claims fraud detection model. We are in phase 2. The data team is super diligent. They learn their lesson from the bank scenario. They conduct a thorough systematic assessment of every single row. They confirm the data set is complete, it is accurately labeled, it is consistently formatted across every single source system. There are no typos and absolutely no nulls.
Sounds perfect. It sounds like the gold standard of data.
However, a data scientist conducting the assessment notices that the data set only covers the last 18 months. Now, think about the world 18 months ago. Let's say purely hypothetically, during that specific 18-month period, there was a massive regulatory moratorium or a global event that made fraud patterns atypically low.
Yeah.
Basically, nobody was committing fraud because the world was on lockdown or the rules had changed temporarily.
Okay, so the data reflects a really weird time.
Right. But the team lead argues, look, We did the documented assessment. The data is accurate to what happened. The formatting is consistent. The timestamps are valid. Data quality is verified. Let's build the model.
Ooh, okay. This is tricky.
It is. So what do you think? For everyone listening, lock in your answer.
Because technically, the data isn't broken right. The numbers are accurate numbers. The facts are facts. It is just boring data. It is data where nothing happened.
So is the team lead right? Is data quality verified?
I want to say yes, because the data is true. But my gut tells me no. If I train a model on data where there is no fraud, and then I release it into the real world where people actually are committing fraud, the model won't know what fraud looks like. It is like studying for a Spanish test by reading a French book. The book is accurate, but it is totally useless for the test.
That is a brilliant analogy. So what is the final verdict?
The quality is bad, even though the data is accurate.
You nailed it. The answer is no, data quality is not verified. And here is the trap. Candidates confuse data cleanliness with data suitability.
Cleanliness versus suitability, that is the distinction.
The data is clean, it is formatted, it is accurate, it is beautiful, but it's not representative.
Yeah.
Verified data quality includes checking for representativeness. If the data doesn't reflect normal operating conditions, like a period with normal fraud levels, it is not fit for the modeling purpose.
So quality in CPMAI doesn't just mean is the spreadsheet neat. It means does this data reflect the reality we are trying to model?
Precisely. If you have a perfectly clean data set of ice cream sales from December, it is high-quality data for analyzing winter trends. It is garbage-quality data for predicting summer sales. The quality is relative to the purpose, not just the file format.
So even if the spreadsheet is beautiful, if it is a snapshot of a weird time, it completely fails phase 2.
Ideally, yes. The memory hook here is verified data quality asks, is what we have good enough? Not just is it messy, but is it good enough to teach the AI the truth?
Is what we have good enough? Okay, I'm writing that down. That distinction between cleanliness and representativeness is huge. That honestly explains so many practice questions I miss.
It is the difference between a clean textbook and the right textbook. You could have a perfectly printed textbook on geology with no typos and high-resolution images. But if you are studying for a biology exam, that book has zero quality for your specific need.
I love that. Okay, I feel much better about quality. It is about suitability. But what about the next one? This is the one with the really long name that feels like it overlaps with everything.
Explore data and cognitive data requirements.
Yes. This is where I just get lost. I always think exploring is just making charts and graphs. But then there's this cognitive part attached to it. An honest question isn't figuring out if the data is representative, which we just discussed isn't that part of exploring. Why are they separate tasks?
That is a really great question. They are deeply linked, but the actual actions are different. In the CPMAI framework, this task has two distinct halves that both must be done.
Two halves. Okay, break them down for me.
Half one is statistical profiling. This is what you are thinking of. Distributions, finding outliers, checking mean and median standard deviations. The math stuff, this is looking at the data to see its overall shape.
Okay, that is the explore part.
Half two is cognitive coverage. This is defining the labels, the intents, and the entities the AI actually needs to know. This is looking at the problem to see what concepts are required.
Cognitive coverage, that still sounds a bit abstract.
Let's ground it. Think of it this way. Here is your metaphor, the casting director.
Okay, we're making a movie. I'm the casting director.
You are. And you have two distinct jobs. Job 1 is the auditions, which is screening the actors who actually showed up today. You look at them and say, okay, we have 200 people in the waiting room. 50 are tall, 50 are short, 100 are non-union, and the average age is 30. That is statistical profiling. You are just describing the inventory you have in the room.
Here is the pile of people we have. I am counting them. I am measuring them.
Exactly. You are profiling the resource. But Job 2 is looking at the script. You need to define the roles. You read the script and say, does the script require someone who speaks Mandarin? Do we need a stunt driver? Do we need a child actor? That is cognitive requirements.
Oh, I see where you're going with this. One is looking at the people, which is the data, and the other is looking at the script, which is the requirements.
Right. Now imagine you do the statistical profile. You say, we have 200 actors, they're all healthy, they're all on time, you verified their quality, but you never actually looked at the script. You didn't realize the main character needs to speak Mandarin. What happens when you start filming?
You are screwed. You realize on set that nobody can say the lines. The project fails.
Precisely. And that gap surfaces in phase 4 or V way down the line when you have already spent all the money.
So statistical profiling asks, what is in the pile? And cognitive requirements asks, What do we need to be in the pile?
Perfect. Let's try a scenario to see if you can spot the difference. This is a medium difficulty one. Listener, make your choice.
Okay, you ready?
A global logistics company is working on an AI shipment damage classification model. They want to use cameras to automatically spot damaged packages on the conveyor belt. We are in phase 2. The data team is super thorough. They profile 300,000 shipment records. They give you beautiful charts, distributions of package weights, missing value rates, outlier analysis on delivery times. They literally have a 50-page PDF of charts. The team lead says, data exploration complete. We know our data inside and out. Let's move to phase 3.
Okay, so they did the charts, they did the audition count, they know the average weight, the average time.
Right.
But did they define what damage actually looks like?
Mhm.
Like, they have charts of weights and times. But if the goal is to find damage, did they define crushed box? Or water damage? Or torn label?
Exactly. They missed the cognitive data requirements. They didn't define the concepts the AI needs to recognize. They know they have 300,000 records, but they haven't defined the label types. Without defining the cognitive requirements, the concepts, the statistical profile is just trivia. It is useless.
It is like knowing you have a fridge full of ingredients but not knowing what you are cooking.
We will actually get to a cooking metaphor later, but yes, you need the recipe, which is requirements, just as much as the ingredients, which is the profile. Now let's do the hard scenario for this one. This is the blame game trap.
I hate the blame game. It is always the PM's fault, by the way.
Usually, yes.
Mm-hmm.
But in this case, let's see. Scenario. A healthcare provider is building an AI symptom triage model. It's a chatbot for patients. The team identifies the symptom categories they need. Phase 2 is marked as done. But later in phase 4, which is model development, they realize they have 0 examples of pediatric symptoms. Kids. And kids make up 30% of their caseload.
That is a massive miss. You can't diagnose a kid like an adult.
Huge miss. Now the project is stalling. A team member speaks up and says, hey, this is a data quality issue. Verified data quality should have caught that the pediatric data was missing. Those guys in the quality team screwed up.
Oh, that sounds, that sounds plausible.
Think about it based on what we just discussed.
Well, if the data's missing kids, isn't that a completeness problem? And verified data quality checks for completeness.
Yeah.
So I would tend to agree with the team member. It is a quality failure. They didn't check for completeness.
And that is the trap. That is exactly where you lose the point on the exam.
Damn it. Why? Missing data seems like a completeness issue.
Verified data quality checks the data against itself, or against the standard you provided. It asks, is the data we have complete based on the rows we see? Are there empty cells? But who tells the quality team that they need pediatric data in the first place?
Oh, the quality team doesn't know the medical requirements. They just check the spreadsheet structure.
Exactly. The quality team checks what is there. The cognitive data requirements task is where you define the need. You have to formally state, we require coverage for adults, seniors, and pediatrics. If you never wrote down we need pediatrics in the cognitive requirements, you can't blame quality for not checking for it. Quality checks if the data meets the requirements. If the requirements are blank, the quality check passes.
That is so subtle.
It is. But is the difference between a bug in the code and a bug in the design. Verify data, quality catches bad data. Cognitive requirements catches missing definitions.
Okay, that clicks for me now. If I don't put pediatrics in the casting call script, I can't be mad when no kids show up to the audition. The casting director, the quality team, just checked if the people who did show up were healthy.
Exactly. The memory hook here is explore data asks, does what we have contain what we need?
Does what we have contain what we need? Okay, that really helps separate it from just checking for errors.
Moving on to term 3. This one seems technical, but is actually about process discipline, training, and test data requirements.
Now, this one feels a lot more straightforward. This is just splitting the data right. 80% for training, 20% for testing. Everyone knows this.
Everyone knows the numbers,
Mm-hmm.
but the when is the critical part, and the how is often messed up.
When?
The definition is setting the rules of engagement before anyone touches the data. You have to find split ratios, time ranges, and temporal leakage controls before phase 3 preparation begins.
Why does it matter if I decide it before or after I clean the data? I mean, I'm agile. I want to see the data, clean it up, see how much I have left, and then decide the split. That just feels practical.
It feels practical, but it absolutely destroys scientific validity. Metaphor time. The blind taste test.
Okay, I'm listening.
Imagine you are running a blind taste test between Coke and Pepsi. To do it scientifically, you have to decide the rules before you pour the drinks. We will have 3 cups. Cup A is Coke cup, B is Pepsi. The taster cannot see the bottles. We will count how many sips they take.
Right. You set the protocol beforehand.
What if you pour the drinks, let the person taste them, watch their facial expressions, see that they seem to like the blue cup more, and then decide, okay, the rule is whoever smiles after the blue cup is the winner. Or you decide after the fact which cup was which.
That is cheating, or at least it is not science. You are rigging the game.
It defeats the entire purpose. If you decide the rules after you have seen the data, you are biasing the experiment. You are tailoring the test to the data you have already seen. You are drawing the bullseye around the arrow you already shot.
So you have to lock in the rules while you are still blind to the results.
Exactly. Let's look at scenario A, medium difficulty.
Go for it.
A telco company. Churn model, predicting who will cancel their phone plan. The data science team says, hey, let's not decide on the 80-20 split yet. Let's wait until phase 3. We will clean the data, remove the duplicates, see what it looks like, see how much good data we actually have, and then we will decide the split.
Again, that sounds so reasonable in a business meeting. Let's see what we are working with before we commit.
It sounds practical, but under CPM AI.
It is a trap. It is the deferral trap.
Correct. And what is the risk?
Evaluation contamination. If they look at the data first, they might subconsciously pick a split that makes the model look better, or they might throw out data that looks too hard to model.
Precisely. You cannot grade your own homework after you've seen the answer key.
Yeah.
You must set the rules first. Now, scenario B. This is hard difficulty. This one involves temporal leakage.
Temporal leakage. That sounds like a sci-fi problem. Captain, we have a temporal leak in the warp core.
It feels like one, and it destroys models just as effectively. E-commerce model. Predicting what you will buy next. Phase 2. The team does define the split. They write down 50,000 records, 70-30 split.
Okay, so they followed the rules. They wrote it down.
They proceed to phase 3. The data prep team takes the data, sorts it all chronologically, oldest to newest, and that applies the 70-30 split.
Okay.
So the top 70%, the oldest stuff goes to training. The bottom 30%, the newest stuff goes to testing.
Wait, isn't that good? You want to test on new data, right? That is how time works.
In many cases, yes. But let's say the requirement was to test if the model works across all seasons, not just future ones, or considered the reverse. Let's say they shuffled it randomly. They took all the data, shook it up, and split it 70-30.
Like random split, that's standard.
If they do a random split on time series data, the training set, the 70% will contain data from December, and the test set, the 30% will contain data from November. So the model is using the future December to predict the past November. In the real world, you can't use next week's lottery numbers to predict today's.
That is the leakage. The model is cheating because it has information from the future that it shouldn't have.
Exactly. Now here's a scenario twist. The model fails in production because it was cheating during testing. The stakeholders are furious. The candidate argument is the team defined the split ratio 70-30 and volume in phase 2. They did their job. The phase 3 team executed the split wrong by shuffling it. This is a phase 3 error.
I would agree with that. If phase 2 said 70-30 and phase 3 did the sorting wrong, that is on phase 3, the phase 2 guys aren't the ones typing the code.
Incorrect.
Why? You are blaming the architect for the builder's mistake.
Because temporal leakage controls are a data requirement that must be specified in phase 2. You have to explicitly write down, do not random shuffle maintain time order or cut off training data at December 31st. If phase 2 didn't specify the time rule, phase 3 had no rule to follow. Phase 3 just saw split 70-30. A random shuffle satisfies split 70-30.
Oh, wow. So you can't just say 70-30. You have to say 70-30, and here is exactly how you handle the timeline.
Exactly. If it is not in the requirements, you can't blame execution. Phase 3 executes the recipe. Phase 2 writes the recipe. If the recipe doesn't say don't add salt and the chef adds salt, it's the recipe's fault.
That is tough, but it makes sense. The requirement has to be complete.
The memory hook here is training and test requirements asks, have we set the evaluation rules before touching the data?
And rules before touching. Got it.
Okay, take a breath. Those are the 3 big terms. Now we move to segment 2, top concepts.
Okay, I am breezing. These concepts are the broader ideas, right? The philosophy behind the terms.
Yes. These are the principles that help you distinguish between the tasks when the exam questions get blurry. First concept. Data quality is evaluated for AI suitability, not just general governance.
This sounds like the cleanliness versus suitability thing we touched on earlier with the insurance example.
It is, but deeper. Candidates often ask if the enterprise data governance team certifies the data. Isn't that the gold standard?
Yeah, exactly. If the chief data officer says this data is compliant, who am I, the lowly AI guy, to argue?
You are the AI specialist. You're the only one who knows what the model needs. Governance checks general standards. Phase 2 checks AI suitability.
Give me a metaphor to separate these two.
The Olympic pool inspector.
The swimming. Okay.
Imagine two standards for water. Standard A is drinking water standards. Is it safe? Is it clear? Is it toxic? Does it meet the city health code?
Right. That is governance.
Standard B is Olympic competition standards. Is the temperature exactly 26 degrees Celsius? Are the lane markers visible? Is the turbulence minimized? Is the depth sufficient for diving?
Okay, I see.
You can have a pool filled with perfectly safe drinking water that completely fails Olympic standards. It might be too hot or too cloudy to see the wall, or too shallow.
So general governance is drinking water. Is it legal and safe? And AI suitability is Olympic water. Can we actually race in it?
Exactly. A governance pass does not mean the data is ready for machine learning. The governance team doesn't care about representativeness or bias in the same way you do. They care about privacy and storage.
That is a really great distinction. So if a question says the data passed the governance audit, I shouldn't automatically assume it passes phase 2.
Never assume that. Hard scenario. Manufacturing predictive maintenance. The governance team certifies the sensor data from the factory machines. No missing fields, timestamps are correct. Privacy is protected. The project manager moves to phase 3.
But the PM is wrong.
Why?
Because they relied on the drinking water certificate. They didn't check if the data was actually useful for predicting machine failure. Maybe the sensors only record once an hour, which is way too slow for AI. That would be the Olympic standard.
Correct. And here's a follow-up scenario, an actual production failure. Financial services anomaly detection. The model fails in production because a specific branch, let's say the rural branches, was underrepresented in the training data.
Oh, we talked about this. That sounds like the representativeness issue.
It is. The trap is thinking this is a training data split issue or a phase 3 issue. But underrepresentation of a real-world category is a verified data quality failure. It failed the Olympic standard of representativeness.
And the one-line contrast here.
Literal governance asks, is it clean? AI quality asks, can the model learn from it?
Can the model learn from it? I love that. It puts the burden entirely on the learning, not the formatting.
Concept 2. We already hinted at this with the casting director, but let's solidify it. Cognitive data requirements are a distinct phase 2 task.
This is the chef metaphor you promised earlier.
Yes. Candidate confusion. I still feel like this overlaps with just knowing your data.
It does feel blurry. Exploring feels like it should cover everything.
Clear it up with inventory versus recipe. Statistical exploration is the inventory. You open the fridge, you count. I have 6 eggs, a stick of butter, and a gallon of milk. You're simply stating facts about what exists.
That is the stats.
Cognitive requirements is the recipe. I am making a souffle. I require 4 eggs, sugar, and chocolate. You are stating needs based on the goal.
And if you don't have the recipe,
you might look at your inventory of eggs and butter and say, we are rich in food. You high-five your team, but you fail to realize you have 0 sugar. And without sugar, you cannot make the souffle.
So statistical profiling looks at what you have. Cognitive requirements looks at what you want. And you need to compare them.
Hard scenario. Legal tech. Contract extraction. The team profiles the data beautifully. They know word counts, file types on languages. But in phase V, they realize indemnification clauses were never defined as a label. The model doesn't find them because nobody told the model they existed.
And the team blames verified data quality. Why didn't you check for indemnification clauses?
They always do. But why are they wrong?
Because you can't quality check a recipe you never wrote. If you didn't write down, we need indemnification. The quality team can't check for it.
Boom. Exactly. If you don't list indemnification as a requirement in phase 2, you can't blame quality for not checking it.
One-liner.
Statistical profiling looks at the data. Cognitive requirements looks at the problem.
That is the one that is definitely going on a sticky note.
Last concept. ML-specific data requirements must be defined before preparation.
The rules of evidence.
Yes. Candidate confusion. Why is before preparation such a big deal? Can't we fix it in the mix?
I mean, we are agile, right? Fix it as you go. Iterate.
Not with data splits. Once data is processed, the evidence is tainted. Metaphor. Rules of evidence in a trial?
Go on.
You have to decide if a piece of evidence is admissible before the jury sees it. The judge makes that ruling in a pretrial hearing.
Right.
You can't show the jury a bloody glove. Let them gasp, let them form an opinion, and then say, oh, actually, that is inadmissible. Please forget you saw it.
The damage is already done. They can't unsee it.
Exactly. If you prepare your data, if you clean it, normalize it, shuffle it without the rules, you've tainted the jury, which is the model. You can't unring that bell. The model has already seen the pattern you were supposed to hide.
Hard scenario. Cybersecurity threat model. Phase V shows amazing accuracy. Everyone is celebrating. 99% accuracy.
That's a
But the test set contained future threat signatures.
temporal leakage.
So the model was cheating. It saw the future. It saw the bloody glove it wasn't supposed to see.
Who is at fault? Phase 3 for building it wrong? Or Phase 2?
Based on what you said about rules of evidence, it is Phase 2. If Phase 2 didn't specify prevent temporal leakage, Phase 3 cannot be blamed.
Correct. It is a Phase 2 specification gap.
One-liner.
Define the rules in Phase 2. Execute the rules in Phase 3. Never mix them.
Okay, I feel like my brain has been completely rewired. I was approaching this like a data analyst just cleaning up, but this is really about being a data architect.
Exactly. You are designing the system, not just scrubbing the floor.
Yeah.
Good. Now let's see if it sticks. Segment 3, rapid fire.
Oh boy. The pressure is on.
4 fast scenarios. 1 sentence answers. I will tell you if you are correct, close, or wrong. Ready.
Ready.
Scenario 1. Data team does a quick spot check on 5% of records and says quality is verified.
Wrong. Spot checks aren't sufficient. You need a systematic assessment.
Correct. Systematic and documented.
Nailed it.
Scenario 2. We found out in Phase 4 we missed refund intent labels. Is this a data quality failure?
No, that is a cognitive data requirements failure.
Correct. You failed to define the recipe needed for the model.
2 for 2.
Scenario 3. We decided the test split ratio after we cleaned the data in Phase 3.
Wrong. That introduces evaluation contamination.
Correct. Rules must be set before preparation.
I am on a roll.
Scenario 4. The data passed the corporate governance audit, so it's ready for AI.
Wrong. Governance doesn't automatically satisfy AI suitability.
Correct. It doesn't check for representativeness or fitness for the model. Perfect score.
Yes.
Look at that confidence shift. You sounded terrified 40 minutes ago.
Honestly, it helps so much to put it in those buckets. Pre-flight check. The recipe. The jury. It makes it real.
So let's wrap this up. Give me your summary. What changed today?
Okay. Candidate summary. Before today, I thought verified data quality was just checking for Excel errors. Now I know it is about AI suitability and representativeness. If the data isn't like the real world, it is low quality even if it is clean.
Spot on.
And I also thought cognitive requirements were just part of exploring. Now I know it's a distinct task to define what the model needs to know the recipe, not just the inventory. If I don't ask for it, I won't get it.
Excellent. Here's my final anchor for you. If you remember one thing for the exam, ML-specific data requirements like splits, leakage, edge models must be defined in Phase 2.
Before we touch the data.
If you wait until Phase 3, you have contaminated your evaluation.
Got it. I feel ready to tackle some practice questions now.
You will crush them. Just remember to
Pick your answer before the reveal.
every time.
Thanks for the deep dive.
See you next time.